aware about the rules, here is a quick introduction for our speaker today. Our first speaker is Miss Mei Chan. Mei is the Senior Program Manager. She led the development of ISO 30500 and ISO 31800 for innovative non-sewered sanitation and the establishment of lab testing and certification capabilities in Africa and China. Prior to this, May served as the program manager with World Toilet Organization when she executed the floating toilet for floating school of the Tonle Sap River in Cambodia. Our second speaker today is Mr. Chris Chan. Chris is the project manager and he has planned and tested various reinvented toilets pursuing product certification according to ISO 30500. He is the technical co-project lead for ISO PC 318, paving the way in developing a standard fecal sludge treatment units, energy independent, prefabricated, community scale, resource recovery units to be published this year. So on that note, I will hand over the presentation to May, who will start with the introduction to the topic. Over to you.
Can you hear me?
Yes, May.
I'm getting conflicting answers on the chat group. Okay, so I thank you for joining us today and welcome to our first of 4 webinar series on understanding ISO 30500 through performance testing, best practices, and case studies. So the objective of today's webinar is to give you an overview of ISO 30500 standard by highlighting key testing, certain key aspects of test requirements, and also to take you through on how the standard is being organized. So this session is not meant to dive into details, and as Minal said earlier, we will be taking and answering any questions you may have during the Q&A session. And for the next few slides, I will be taking you through on how and why we developed the standard. So some of you may find this slide familiar, but I think for the benefit of the rest of the participants, this slide in the green box, it kind of shows the scope of the standard. So this standard ISO 30500, the full title is Non-sewered Sanitation System, Prefabricated Integrated Treatment Unit for general safety and performance requirements for design and testing. It is a standard for on-site toilet technology that collects, contain, and fully treat the waste on the spot without transportation. Okay, and why is this standard called a forward-looking standard? It is because this standard was developed alongside with emerging innovative sanitation treatment technologies. It is a performance-based standard and also technology agnostic. It also requires 100% pathogen kill to ensure the outputs are safe for human health and the environment. And on the right-hand side in the gray box is another standard currently still under development, where TÜV has also led the technical discussion in PC 3018. And the standard should be published by end of this year. However, it is not the topic for discussion in this webinar. So from the inception of this idea in 2015 to the publication of the standard in 2018, it has been a very sharp learning curve for not just for TÜV, but also for many of our partners and labs whom we had conducted testing with. So I'll start with landscaping of technologies. In 2015, a few of our colleagues traveled across various countries and conducted a landscaping of existing toilet technologies to understand why current on-site toilet technologies fail to provide safely managed sanitation. In addition, we also studied in detail some of the emerging toilet technologies to understand the process of such treatment units. And as a second phase, we have to form a technical committee to seek advice and inputs from experts and various stakeholders in the sector to help us draft the initial criteria for the standard. And the stakeholder that we invited came from various backgrounds, including industrial experts, university professor, and various stakeholder practitioners, WASH practitioners. In fact, I myself was part of the initial technical committee member back in 2016, and I represented a World Toilet Organization. And the rest is history. How and why I became a TUSUD and now leading the project. So after we formed the technical committee, what we did was we took all the inputs back, the ideas, the questionnaire that we had, and start to formulate criteria for setting the standard. In addition, we did an extensive landscaping of many different standards, looking at what are the discharge limits that's applicable for certain technology, certain processes. This whole thing is a completely iterative process that took several years to complete. And the final stage was taking the standard through the ISO process, and ISO Project Committee 305 was formed. So the last part to get the standard published and approved was the formation of a Project Committee PC 305, and 46 countries were involved in the development of the ISO 30500 with 32 participating members and 14 O members. In the final meeting in Kathmandu in 2018, there's 88% of the country members of ISO voted yes on the standard. And it was published in November 2018. So the key message on the last previous slide is to share with everyone that this standard has gone through many rounds of seeking input from experts and international stakeholders to come to where it is at this moment. And also for TUSUD, when we were developing the standard along with the project committee PC 305, we have done quite extensive validation of the standard. What that means is we have worked with partners to do testing on the method that has been outlined in the standard to make sure that it's sound, to make sure that it makes sense. And we have also tested on some commercially available system to test the method that was outlined in the standard. So it is actually, the process that we took was quite a robust process to make sure that the standard is achievable and it meets certain, it helps to make sure that the outputs of the treatment technologies is safe for the environment and human health. So this slide that you're looking at can be found in the scope of the standard. So it shows that the standard consists of is for toilet technologies that front end and back end for collection and the conveyance itself within the system. And this standard is quite a comprehensive standard. It covers testing from mechanical to electrical, EMC. And in addition, when I say the standard is a performance-based standard, we have requirements for safe solid and liquid discharge or reuse, air emission, odor, and noise. So the way the standard is structured, it can be grouped into three groups. So if you're a manufacturer going for certification or someone trying to understand the standard so that you can adopt it in your country, the way the standard is structured, we look at document checks, control lab testing, and field verification of performance. Under document checks, there are quite a few number of things that as a manufacturer you need to produce to be able to meet these requirements. And under control lab testing, the major clauses are loading patterns, mechanical requirements, environmental parameters, human health, air emission, acoustic, odor, and electrical that falls under control lab testing. And then for field verification of performance, we have the field testing guidelines and environmental and human health parameters. This standard has three types of certification classes. So class 1 and class 2 is when you have one front end, and if your back end treatment is using non-biological, then you fall under class 1. If your back end treatment falls under a biological process with one front end, you fall under class 2. And if you have multiple front end, like an ablution block, and your treatment technology can be either biological or non-biological, as long as you have more than one front end, you fall under class 3. So for class 1, 2, and 3, you have to go through the same document checks requirements, and you also have to go through minimum 32 days of controlled lab testing. The difference comes in is the field testing. So if you are class 1, and you are using non-biological treatment process, you go through field testing for a minimum of 30 days. If you're class 2, so one front end using biological testing, your field testing has to be minimum of 5 months. And if you fall under class 3, you have multiple front ends. And if you are biological system, then your field testing is minimum of 5 months. However, this class 3 system, in the standard, it has outlined if you have more than 2 to 5 front ends, you need to randomly select 2 for testing. And if you have more than 5 front ends, then you have to test at least minimum 3 front ends. So I have finished with the introduction to ISO 30500. For the next section, document check, we will be showing 2 video scribes that will last for 5.5 minutes. So I'll play the scribe right now, and if you can't hear the audio, please type into the chat box and let me know.
Of the standard is for documentation checks. This section includes all expected documentation from the manufacturer, as well as any tests that are required due to missing documents. The first clause of documentation checks is general technical information. This outlines all information the manufacturer is expected to provide. This includes the system's treatable input, capacity, minimum wait times between uses, how to safely dispose of menstrual hygiene products, and the serviceable life. The standard also specifies how the information can and should be shared. For example, the minimum wait times between uses should be in the user manual or on a data plate located in the system. The next section, General Safety, outlines all general physical requirements of this system. Some of the general safety requirements are: assembly design should deter removal or dismantling of critical accessible system parts. The toilet should function in an environment ranging from 5 to 50 degrees Celsius and within 20 to 100% humidity levels. Gas and accumulations, slagging, blockage of exhaust, and other potential hazards should be monitored, and the necessary mitigation measures should be implemented. These risks should also all be outlined in an iterative risk assessment created by the manufacturer. The following section is process design safety. This will include regulations on water seal depth, piping and connections, and mitigation measures through physical design to prevent infection from pathogens. It also covers safety measures for effluent reuse. For example, if hand washing water is produced by the system, it will be expected to meet WHO guidelines. Section number 4 in documentation checks is material safety. This section highlights all components and part requirements like cleanability, grip finish, durability, and fire resistance. Next is mechanical and electrical safety. Each of the subsections applicability to the system is dependent on the system's features. For example, if the system has pressurized equipment with pressure levels greater than 50 kilopascals, or vacuum equipment with pressure levels lower than 50 kilopascals, then it must withstand mechanical loading pressures and structural strength safety factors. Other features covered in this section include pipes, hoses, tanks, extremely hot or cold surfaces, subsystems with radiation emissions, and all moving and rotating parts.
Next video.
The first part of the standard is
Sorry, I have to get out of the screen and click on the next one. There we go.
The following section is user interface experience. This clause covers all user features from cultural requirements to markings and labeling. The standard describes the need for a toilet that will fit within cultural norms. Is the community used to water or dry flush, a squat or sitting toilet, toilet paper or water wash? The system should be comfortable to the user and achieve aesthetic satisfaction, and any labels, signs, warnings, and markings should be in the country's official language. This clause is intended to provide the user a safe, comfortable experience so the technology can be seamlessly implemented into the community. The clause maintenance design lays out the expectation that the toilet's maintenance, cleaning, and other upkeep is reasonable and within community capabilities. Maintenance activities and frequency of those activities are doable for users or professional service personnel on site, and all components that need to be replaced or serviced are easily accessible. Normal cleaning should not put the user in contact with hazardous material, and if it does, a trained service personnel should be required. User manuals are written in the local language and English language. And lastly, the full system shall be safely transportable. Sustainability is the last clause of documentation checks. This clause highlights the use and recovery of resources from the system output. Manufacturers will be expected to estimate the amount of nutrients like phosphorus and nitrogen in the final solid and effluent output. The proportion of the system's effluent and energy that can be recovered in comparison to its consumption level needs to be provided by the manufacturer as well. A life cycle assessment should be conducted as per ISO 14040 and ISO 14044. Interested buyers should also be provided with recurring operational requirements, estimated annual energy consumption, and freshwater input in order to compare between systems and better judge the alignment of a system with their given location.
All right, so the two video scribe have also given a high-level summary of what document checks are required. From our experience with testing with some of our stakeholders, document check, please do not underestimate the amount of time to get it ready and prepared to qualify for the standard. There is a lot of work behind document checks actually. So without further ado, let me introduce you to the next speaker, Chris Chan. Chris, could you take us through the next couple of sessions, which is the control lab testing and field testing?
Okay, hello. Thank you, Mei. Okay, so hello everyone. So my first slide, okay. So before going into the controlled laboratory testing requirements, I'd like to share with you one of the first key things before starting the test. They are basically the schedule of the entire test, and then how feces and urine will be loaded into the system during this period. Okay, so as you can see here, the schedule seen here is the schedule given in the standard in table 3. So I'd like to bring you through this schedule because it's quite important. It basically covers the entire controlled laboratory testing requirements. So as you can see here, the first column here depicts the kind of test, the kind of test that's being done. The second column here is the pattern. This is what type of loading for the particular day. So we have color-coded items for better visibility. So in the GIS, there are a total of 5 days in yellow for human health and environmental parameters for solid and effluent outputs. So there are 4 days of odor testing here in purple, and then 2 days of air emissions and noise testing in green. So as you can see here, for the loading pattern, most of them are normal loading. And then you can see that there are special circumstances for diarrhea and stress testing. The purpose for this is to test the consistency of the results under different load conditions or under different users. So the normal loading pattern is derived from the capacity calculations indicated by the manufacturer. The loading time is spread across 6 a.m. to 8 p.m. This is to simulate closely to real case scenarios or usage of a regular working adult. So the loading here is they are either collected and loaded manually, or they are deposited by users using the toilet directly. So as you can see here, there's a different loading patterns here. The stress loading is basically the normal loading plus 80% of the difference between the max and the normal loading capacity given by the manufacturer. And then the diarrhea is basically simulated as the worst case scenario where half the users are having diarrhea at a particular day. So the diarrhea calculation is basically feces diluted with water at a 2:1 ratio. Okay, so for the mechanical tests, they are mainly focused on the front end and front end area. So these tests are all listed out and given in the ISO 3500. The steps are all there. So these tests are not indicated in the schedule if you have noticed earlier, but yes, because this is required to be tested prior to commencing of the controlled laboratory testing. So for the environmental and human health parameters, we'll not be covering in this webinar. They will be covered by our colleagues in the next few webinar sessions in the coming weeks. So please remember to join us. So jumping into the next would be air emissions parameters. The air emissions testing is separated into 2 sections of testing. Testing of the air emissions indoor at the front end, and air emissions at the stack area. So this is to be noted that the stack area is not the outdoor area or the atmospheric testing. So these are the parameters for the front end as shown. And then we'll go through it later. And then these are the parameters for the back end or stack. Okay. So as you can see on the table 11 on the left here, the threshold of the parameters are based on 1 hour average sampling time, except for H2S, which is measured in 30 minutes average. So the recommended methods are provided as well, but please note that the air emissions testing methods can be used, the other equivalent national standards are acceptable as well, instead of the ones listed in the ISO 3500. So as you can see here on the photo on the right, the required testing or sampling is as shown. It should be at least 1.5 meters above the ground, 1 to 1.5 meters. And then it should be above the squat or the seat pan. The superstructure door should be closed to avoid cross-contamination with the air outside as minimal as possible. And then usually for laboratories in ppm or ppb values, the thresholds are based on ideal conditions. So if you want to convert it back to mass per volume, it would be based on these conditions. For the stack emissions, the parameters are all based on 1 hour averages with concentrations normalized to ambient conditions. So similarly, equivalent national standards are acceptable as well. As you can see in table A13, they're all recommended. But if you have a national standard that is similar or equivalent, you can use it as well. So the picture on the right here is taken from EPA method 1A. This method provides you as a guideline on how to do the measurements for stacks using best practices. So as you can see in the photo here, you see the sampling point. Before and after, you should have a clearance of 8D from any disturbances. So this is to give it a better laminar flow so that the collection can be more accurate. Okay, so moving on to acoustic parameters. This is similar to air emissions. The noise or acoustic test is separated into indoor, which is within superstructure, and then external, which is around the back end process. So for the front end, the requirement is just a single point measurement above the squatting or sitting pan, 1.2 meters above the ground. So as you can see on picture A, this is the correct setup. There's a common mistake for people using picture B because they interpret as 1.2 meter above the seat pan, which as you can see in B is a bit not correct. It's a bit too high for the measurements. So the measurements of this basically is for measurement of the front end, how loud it flushes, or even if there's any noise coming from the back end system. And for the back end system, the measurement procedure is usually, as you can see on the photo on the right here, you have to find the midpoint. So usually it is 1 meter out and 1.2 meter height. And then the measurement should be at intervals of 1 meter. Yep. And as you can see, not all systems has exact 1 meter intervals. So definitely you encounter at the end there is less than 1 meter. So these less than 1 meter points, they will be discarded. So moving on to odor requirements, this is similar to the previous two parameters. This is also separated into within superstructure, which is the front end again, and then external or vicinity of the system. So before even going into the test, there's a requirement from ISO 3500. The details, the step-by-step method are all inside the standard. Before doing the test, a set of 4 panelists have to be selected and screened from the general population to serve as panelists. So this is to ensure that panelists do olfactory sensitivity is within a defined bandwidth, and also to ensure repeatability during the test. So in short, to say that the panelist does not have a too sensitive nose or a not as sensitive nose. So the panelists are assessed by smelling through different bags or using an olfactometer that you can see on the right over here, the photo, with different concentrations of H2S, mainly neutral, that is natural air, 0.01 ppb of H2S and 2 ppb. So the panelists are then accepted based on their perception test as per the table requirements. So they have to pass the test over here. So the location of the test is at the front end. And also for the back end, there'll be a plan on how to do the test. This is based on the laboratory's planning and requirements. So the record is done every 10 seconds for 3 minutes. So for typical odor test day, there'll be 10 events. 4 for fecal, as you can see in number 1 here. 2 for urinal. 2 for events when the odor is released the most, or assumed to release the most, and then 2 randomly. So at the end of the test, the results have to be tabulated and meet the minimum threshold given in table 9 or part 2 here. So as Mei mentioned, the different classes of the system, based on the number of front ends you have to base on that table to determine how many front ends to test for. So on the right here, coming back, the panelists will have, this is a sample assessment report sheet that each panelist will have. Once all the tests are done, they'll go back to the lab to do a consolidation. So as you can see on the table here, this is the tabulated results for the entire test. And then at the bottom here is the summed up results for 3, which is unpleasant, and 4, which is unacceptable. So at the end, you get a percentage of the total test results, and then based on the ISO criteria, less than 10% for 3, and then less than 2% for 4, which is unacceptable. It determines you have passed or failed the odor testing. Okay, so moving on to the electrical requirements. So the control system shall be tested prior to the test sequence. As you can see, there's no, it's not stated in the schedule. So, and a test plan needs to be developed that incorporates the test cases, enabling each control system function to be tested independently. So the tester shall not be someone who is involved in the testing as well. Or, sorry, the design process. So the second part here is the energy discharge. How this is being tested is at the end of the 32-day testing, this is the last test that's being done. The plant or the system is disconnected and powered down. If there's remaining power to be discharged, they have to be done as per manufacturer's instructions. Once all of this is done, the lab will come in to verify and record any remaining energy that's left in the system itself. So this is basically what needs to be done for electrical requirements, which is quite simple. So next I'll be going through briefly for the field testing. This is usually done after the controlled laboratory testing. So as you can see, the requirements for field testing here are mainly to determine the performance of the system for actual usage scenarios and longer period of time compared to the controlled laboratory testing. And these are mainly only for environmental and human health parameters. So for class 1 non-biological system, as you remember in the previous table, the entire test duration is 30 days. And the test frequency for environmental and human health is on a weekly basis. So every week, the laboratory will come in and take a sample and go back to the lab and produce a result. For class 2 and 3, biological systems only, the entire test duration is for 5 months. So similarly, the test frequency for environmental is weekly, but the human health is tested monthly basis. So all in all, in order to pass the field testing requirements, at least 75% of the environmental parameters needs to pass, and 100% of the pathogen removal or human health parameters need to pass. So this slide here shows better visualization of the different class and the different frequency of testing. So as you can see, the W here is weekly basis sampling or testing, and then M here is monthly, C is when it completes the test, and then you notice here there's D, there's daily sampling. This is required for this prior to commencing of the field validation, which is week 0. So 1 week before, the lab has to analyze and collect samples on a daily basis. This is mainly used in the reduction percentage calculation of total nitrogen and total phosphorus. Which will be covered in our next few webinars. So this acts as a baseline, basically. So I'm coming to the last part of field verification here. As mentioned, this will be covered in the next few weeks. So please remember to join us. So this is my final slide. With this, I come to an end for my part of the webinar here. So I'll be handing over back to Mei to take you through the rest of the webinar. Thank you.
Thank you very much, Chris. Okay. Just to wrap up our webinar, I would like to stress that the ISO 30500 is a voluntary standard. And TUSUD has created a full certification mark for the standard. And the way, because the standard is structured, you can also, if you have a product that doesn't have a front end, so the seat pan, or it's not a one unit, then where your treatment technology is, then you are able to test for the back end. So it is a voluntary standard, and we really highly encourage manufacturers or small business owner SMEs who are considering to take on such to go for certification, to go for as many tests as possible, either internally or find a third-party testing body, because it is quite a tedious process, as you can see, to get the full certification for ISO 30500. But having said that, like any company going for certification, it would be very beneficial for yourself to have done more compliance tests and find out where you are in terms of achieving the certification, the standard. And just to sum up, I would like to share the last video scribe for 30 seconds.
Of ISO 3500, a standard that breaks down into 3 main inspections and testing: 1 laboratory, 2 documents, and 3 field. Each provides the information on what is expected, the schedule of testing, and how it is to be tested. The safety and success of the technology rely heavily on the in-depth and multifaceted knowledge organized in the standard. And that covers.
So I need to, okay, there we go. As I said earlier in the beginning, we are actually, this is the first of 4 parts of the webinar series, and the next part 2 and part 3, we will dive deeper into the microbiology section and environmental parameters. The reason why we took them out from today's webinar, because this 2 section is quite a big chunk in the standard itself, and we have a lot of things to share. And the last part will be introduction to test procedures, and also some of the best practices that we have experienced and collected from the various tests that we have conducted. Last but not least, thank you to all the participants who have shown up today. And these are some of the photos that throughout the past few years that show our, some of the work that we've done, either as a project lead in developing the ISO standard in PC 305, or validation testing in some of the test sites in India, South Africa, and China. So now is the Q&A session, and I'll hand this over back to me now.
We will now begin with our Q&A session with me and Chris. Here is your first question. Will lab testing and field testing be done concurrently?
Okay, so maybe I'll start. We do not recommend to do so because one fundamental reason is because if the system fails either of them when you are testing, you or the manufacturer might need to go back to the drawing board to redesign and redo the testing all over again. So this doesn't really make economical sense if you have to do it concurrently. If one fails, you have to redo everything again, and then you multiply the cost by maybe half or even double.
Thank you, Chris, for answering that. Moving to the next question. How do you verify that WHO drinking water guidelines are met? For example, if water is to be reused as hand washing water?
Yeah, so you are correct. The WHO drinking water guidelines is only a guideline. It doesn't state what should be done. So, but many countries have regulations based on this guideline. They have come up with their own regulations on what drinking water requirements should be. So saying that is when you are trying to certify a system in that particular country, you have to follow the particular requirements using that guideline. And also, as a certification body, we will also want to know where you'll be focusing um, your product in which countries. So, for example, if you have you're manufacturing your product in China, and you might want to sell it in Singapore or even Malaysia or even France. So as a certification body, we'll get all these requirements for these drinking water requirements in these countries, and then check if you really comply to um, the different country requirements. Yeah.
Maybe can I just add on to that as well? So in this standard, we do not verify the reuse of your product. So in the standard, there are requirements for effluent, and you have to meet the requirements outlined in the standard. However, that's for effluent and that's for discharge. If your toilet technology as additional step can produce drinking potable water, then you have to meet your local drinking guideline, but it's not under the scope of the standard. So we can't verify if that's what you meant as part of the certification. It doesn't come under the scope of the standard. Thank you.
Thank you both for answering that question. Here's your next question. Considering the current scenario of COVID-19 and the risk of contamination via the wastewater, are you considering any specific measures for it?
I'll take the question. I don't actually get what you meant. Perhaps the person who raised the question, you can further clarify in the chat box, because the toilet technologies, this standard ensure 100% pathogen kill. That's for solid and for effluent. So when you say consider a specific measure, I actually don't get the question very well. I'm not sure if Chris or anybody else can jump in to answer this question.
Yeah, so thanks. This is Rajni here, and I think I can try to understand Seychelles' question regarding the COVID-19 and risk of contamination. If I get your question correctly, maybe what you're referring to is that during this COVID-19, there would be increase in the number of say pathogens or say virus in the wastewater, and if we have considered that. And assuming if that is the question, my response to you would be that in this standard, as my colleagues just presented, we have two kinds of testing. One is the control lab testing and another one is the field testing. So in the field testing is usually done after the control lab testing. And when you will hear my seminar in the future, like within next 2 weeks, you will realize that in the control lab testing, we also have something called spiking, where we add additional numbers of pathogens in all the categories, like bacteria, virus, or helmet, to make sure that the numbers are taken care of such unfortunate situations where, or scenarios where there is an increased spike or sudden increase in the numbers in the wastewater fecal during this scenario. So we call it spiking. So we have spiking, and the numbers used in spiking will take care of the risk as of now. Yeah, thank you.
Thank you, Rajni, for your insight there. The next question is, can you also give examples of different systems, like you mentioned, non-biological, biological, and mixed?
Yes, so for non-biological systems, we are seeing systems currently that's being developed. They range from filters to incineration to pyrolyzers to mechanical shear force to many different kinds of stuff. So these are roughly non-biological. Anything that's biological, they are mainly, as you can see in the conventional wastewater plants, they are like anoxic tanks, aerobic tanks, and then yeah, the conventional wastewater system layout or technologies. And then you have the mixed ones. They are, say, something like biological and non-biological mixed. Biological is quite straightforward. The non-biological mixed with the biological would be MBR systems, membrane bioreactor systems, plant wall systems. We have seen before electrochemical reactor systems together with biological systems. So there's many around the market and developing at the moment. So maybe you just Google and type maybe reinvent the toilet or stuff like this. Things will come out basically.
Thank you, Chris, for that. Moving to the next question. As air and sound measurements are gap sample, does standard specify the time periods of sampling?
Mm. So air measurements, the periods of sampling I mentioned in the slide previously, indoor is 1 hour, except H2S. Stack measurement is 1 hour. And then sound measurement I didn't mention is actually in the standard, which measures for 24 hours, or if the process or cycle can be completed within a lesser time frame, they can be measured according to that cycle. For example, a process takes 5 hours or even 1 hour to complete its entire process of treating the waste input into able to discharge effluent within 1 hour. So the noise testing is only tested for 1 hour. So it is possible for that.
Thank you, Chris. Here's your next question. Why is the field testing duration for non-biological system so much shorter than biological system, that is 1 month versus 5 months?
So biological systems, I think, as you know, it needs more time to stabilize its treatment process. So for its bacteria to grow, initially during startup for a biological system, you'll see that the removal efficiency or certain parameters are usually low. And then what a biological system operator usually do to make it stabilize is, because there's a lot of water in the tanks, usually what operators do is either they recirculate the effluent back because the efficiency or removal efficiency is not there, or they try to concentrate the effluent in the system to build up, basically to stabilize the entire system. It takes more time.
Thank you, Chris. Moving to the next question. Does the standard define criteria to be a panelist for Odour test?
Okay, so the criteria for panelists, basically, if you're asking if it should be gender, what kind of gender, what kind of age, is there any other requirements other than what's stated in the standard? The answer is no. Even for you can get students or even anyone who is the general public, it should be fine as long as they pass the panelist assessment that I mentioned earlier in the slide.
Thank you, Chris. The next question is, For field testing, are the technologies or systems meant to be tested in all the markets where they are used, or just a few representative markets?
Are the technology systems meant to be tested in all the markets? Oh, okay. um, Basically, there's no requirements in the ISO. So basically, what we do, because an ISO doesn't make sense to be tested in the market that they'll be using for. Because, for example, if you're a new system, you want to get it certified. Once you do the controlled lab testing, you send the system over to, say, Singapore because it's being used there. What if it fails? You have to send the system back and then you have to do a redesign. So there's a lot of risk involved. So basically, as per the standard, it is sufficient for the testing to be because basically there's no location mentioned in the standard itself. So if you are manufacturing in China, we would recommend you do the controlled laboratory in China because there's less logistic costs involved, and also the field testing in China as well, or the particular country you manufacture. This is all for efficiency and risk reduction of the risk.
Thank you, Chris. The next question is, could you please define the three classes again and provide some examples?
Uh, so to define the three classes again, as you can see on the slides here, class 1, class 2, and class 3. Class 1 is for non-biological systems. Class 2 is for biological system, and class 3 is both, either a biological system or non-biological system that has more than one front end. So basically, what's the difference between class 1 and class 2? They are biological and non-biological. What's the similarity between class 1 and class 2? Both are one front end only system. So for class 3, it's just that it's any biological or non-biological system that has more than one front end. That means there's 2, there's 3, there's 4 front ends. So just to add on, I think some of you might be confused. In the field testing, we mentioned that class 3 is, or the 5 months testing is only for biological system. So this is a separate question, separate issue here. So for field testing, only the class 3 biological systems are only the class 3 biological systems are applicable for 5 months. If it's a class 3 non-biological system, you just have to go for 30 days of field testing.
Thank you for that. The next question is, how to incrementally achieve compliance with the standards in low and lower to middle income countries, given that the cost of compliance is often passed on to households? Is there a way to adopt a graded approach to performance, especially treatment, for example, for BOD, COD pathogens?
So let me read the question.
Sure. Okay, so let me divide it in two parts. First part is how to incrementally achieve compliance with the standards in low and lower to middle income countries, given that the cost of compliance is often passed on to the household. Second part is there a way to adopt a graded approach to performance, especially treatment, for BOD, COD pathogens?
Maybe I can take that question. So well, when you say incremental compliance with standards, so this, whether the cost will be passed on to households for getting a certificate, that's really up to, I would say, the buyers of the technology and also the manufacturer. But this standard is meant to safeguard, the current existing way of disposing untreated fecal sludge has caused a lot of issues, health issues. And we want the idea of this standard is to make sure that not only human health parameters are safe, but the technology itself is also functioning properly. So to answer your second question, there's no graded approach. You might encounter some manufacturers who goes for partial compliance, which means they test certain part of the standard, but that's only compliance to, for example, my electrical functions are safe, but they will not be able to get the full certification of the standard. You can't say that I fully comply to the standard. Complying to parts of the standard doesn't give you a full certification of achievement. So yeah, so if you want to be certified according to ISO 30500, then you can't take a graded approach.
Thank you, May, for answering that. This is the last question for the day. One of the participants says, I thought this ISO was specific for user interface plus contaminant and treatment on site, or the collected waste gets transported to a treatment site. Please confirm.
So yeah, I think May is going to the slide for this. So as you are correct, the ISO is specific for user interface, containment, and treatment on site. The one that is being transported to a treatment site is 31800, which is not in this webinar and is still being developed.
All right, thank you, May and Chris, for your time. Due to time constraint, we will not be able to take any more questions for the day. If you have any more questions, please write to us at your respective country's inquiry IDs. We will answer them for you. You can also write to us on the same email ID if you want to request for webinars about our offerings. I'm sure this webinar was interesting and relevant for all of you. Please do visit our website where you will get the latest news and updates about our services. Thank you once again for your time and have a good day.
Thank you everyone, and thank you, Mina, Koran and Fida, the marketing team, for making this happen, and thank you for my colleagues who are online to support the whole webinar series. And thank you for all the participants, especially those in the US and Canada, still up at this hour. We really try to see if we can host a session for the other side of participants. Thank you.